Need to find out minimum shortest path with Dijkstra algo. Today we are going to learn. So this is the graph. So initially what we will do, we will suppose that for each and every vertex the minimum is infinity, because we are supposing it as infinity, and the parent of B is also nil. The similar way for A minimum value is initially infinity and A parent is nil. Right? For in that way we will write for every node D minimum is infinity we are supposing, and D parent is nil. Initially we are supposing C minimum is infinity and C parent is nil. E minimum is infinity and E parent is nil. A similar way for F minimum is equal to infinity and F parent is equal to nil. Now if we are choosing A, because from somewhere we have to start, so suppose if we are choosing A, so we are deleting, we can say we are deleting A node. We are deleting A node. So how we are going to do in min heap, we'll see here how we are going to work on min heap. In min heap, how we are going to do, initially we are writing all the nodes A, B, C, D, E and F. These many nodes are there, and initially as we have supposed the value is infinity for everyone, so we are writing here infinity, and parent we are supposing as nil, so I am writing here n. So how many time we have to do all this? Suppose n number of nodes of there, or sorry, v number of vertices are there, so we can say order of v time we have to put all these things. Initially infinity value and parent as nil, and if suppose we are deleting A, because we have to start from somewhere, so we need to put its value as 0. So what we will put? We will put its value as 0, and parent will remain nil because we are starting from A point. So how many comparisons occur? Because we need to find out now we need to find out which one is minimum value, so order of v time we have to do comparison to delete with minimum value, because we need to find out shortest path, so we will delete the minimum value node which is carrying. So order of v time we have to do compare, because now all the nodes are there, so total v number of nodes are there, v number of vertices are there, so order of v time we are doing comparison, and here we are deleting a node, so log v time, because we are doing comparison with minimum weight and we have to compare on each and every vertex. Initially we have to put all the values, so order of v time. So now this is deleted, so now we have to update the values also. After that we have to update the value, because initially values are infinity we have supposed and parent we suppose nil. So if we are updating values from A, so we can write like this here first, so that it will be easy to understand. A minus A will be 0, no distance. A minus B is equal to 5. A minus C, if we take A to C, it's 10. A to C, it's 10. So we are writing here 10. Then A to D, if we are writing A to D, that is 20. So we are writing here 20. Then A to E is 13. It's missing over here. I have not written its value over here. Okay, we will see here. A to E is not 13, it's 15. Sorry, it's 15. A to E is 15, and A to F is what? A to F, there is nothing, because there is no direct H from A to F. So A to A 0, A to B 5, A to C 10, sorry, not A to C, A to C 10, A to D 20, and A to E 15. Right now, right now it is carrying 15, and A to have no direct edge is here, so we will see. And what will be the value and what will be the value at the end. Initially these are the values, so at the end we will see these values get changed or not. So we are deleting A node. So what is left here, what is left over here? Yeah, so this is deleted, A node is deleted here. So now we need to change the values also here, we will change. So because A is deleted, so adjacent edge we will change the value. So here the value will be 5 and its parent will be A. And in the similar way, the D value will be 20 and parent will be A. C value will be 10 and parent will be A. And E value will be 15 and parent will be A. And F, there is no direct edge from A to F, so we will leave it, we will see later. Now we are coming to next point. So after that, what is left over here? So we will write all these values here. At B, what value we have? We have 5. So we are writing 5 and its parent is A. C, 10 value and its parent is A. D, 20 value and its parent is A. E, 15 value and its parent is A. And still it will remain same. The value is infinity at F and its parent we don't know. Nil, we are supposing now. So now again decreasing key which is having minimum value, we are going to delete. So log V time, because we are doing comparison from all, so log V time. And here, because here we have done changes order of V, because we have put all the values as infinity initially and all the parents are null initially. But now here how many changes occur? 4 changes are occur. Fifth one is not changed because we have not reached from A to F, so we have deleted only A. So we can say how many changes? 4 log V. 4 log V. 4 changes. Log V time we have to do comparison and all, so 4 log V. And here we are, for deleting purpose, we have to compare which one is the minimum value, so log V. So we have deleted B here because B is having minimum value, so we are deleting B node. Now coming to the next point. Again, now we are deleting B, so anything has changed over here, we will see here. Now we are deleting B. So if we are going from B to C, its value is minimum, so we are not going to change it, is okay. And B to F, yeah, 1 point is there from B to F, so its value is 60. Because initially we have not changed its value because it was not connected directly from this A. So now we are going to change instead of, yeah. So the value will be here at B, value is what? 5. And from B to F, what is value? Value is 60. So total will be 65. A to B, value is 5. So B, what is the value? 5. And from B to F, if we are going, the edge is with 60 weight. So total will be 65. So we are writing here 65. And the parent will be B now. Parent will be B now. So now we are going to change again. So what will be the change? Here it will remain same. This will remain same. This will remain same. Yeah, this is going to change now. 65 and the parent will be B now. Parent will be B now. Rest we are not going to change because the rest values are already minimum and there is no direct edge. If we are going to change this will be maximum, so we are not going to change. This is we are going to change, and there is no direct edge from E. And if we are going to B to D also, so this is 30 also, so we are not going to change because this is 20 already. And B to E, there is no direct edge, so nothing will get changed. Only this one will get changed. Only this one will get changed. So we can say how many comparison? 1 log V. 1 log V, because we have changed one, but we have compared also 1 log V. Now again we need to delete the minimum one. So which is the minimum one? This one. So again how many comparison? Log V comparison, and we are deleting C node and log V comparison. Log V comparison. Now we are coming to the next point. The next point is what? Again now we are deleting C. So from C something is changed. We need to see if we are deleting C. From C to F, yeah, there is edge. And at C, what is the value? 10. And C to F, what is the value? 2. So instead of 65, what we can put over here? 12 because this is minimum. 65 is more and 12 is less, because at C what we are having 10, and if we are going to C to F, what is the weight? 2. So total will is 12. So we can replace it. So now the parent is C and the value is 12. So one change happened over here. Or any other changes? No other changes, because from C to E if we go, so yeah, one more change is there. What? That if it is 10 and it is 3, so 10 plus 3, 13. Here it is 15, so we can change over here. So we are changing 13, and here it parent will be C. So these two changes occur. Rest there is no change, because there is no direct H from C to D, and AB already deleted. So these many changes, right? So now we are writing the updated one. So what will the value? 20A, and here it will be 13C, and here it will be 12C. So how many changes occur? 2 changes. So we can say 2 log V comparison and 2 changes, right? Now we have to delete the minimum one. So again log V comparison we have to do. So we are deleting F node and log V comparison. Now what is left? 20A, 13C, right? Yeah. So now which is left? D and E left. So if we are deleting E now, because E is the minimum one, so if we are deleting E, there is no H from if we are taking E to F, so it is 13 plus 5, it will be more, so that is okay. If we are deleting E, so E 13 plus 5, it will be more, so 12 is okay, no problem. So we are not doing any modification over here. So we are simply saying that how many comparison? 0 log V. And if we are deleting this, so again log V comparison we have to do, which one is minimum. So we are deleting over here E and log V comparison. Then what is left over here? 20A. So there is no such changes over here, because this is the last one. So we can say order of 0 log V, and here we are deleting D, so log V comparison. So we can say total the time complexity for Dijkstra algo with this example, we can say the V number of vertices plus V log V plus E log V. How? We can say how many edges? These many edges, log V time comparison. So we can say from here how many edges are there into log V. So this is from left hand side, right? Plus E log V means how many changes we are doing, how many edges are connected, how many changes are occurring in the graph. It based on the how many edges are connected and with less cost. So it will be plus E log V and total number of vertices. So we can say simply, if we add them, we can say, if we are not going to add this, because maximum we are going to take, so V log V plus E log V, or we can say order of V plus E log V. This is the time complexity of this Dijkstra algorithm. Now we are going to make the final graph so that it will give more clarity. So from here A to B 5, A to D 20, and A to C 10, C to F 2, and C to E 3. Because what we have taken, A to B 5, A to D 20, it will remain same. It was same, A to 5 and A to 20. So, and A to A 0 is correct, A to B 5 is correct, A to D 20 is correct, right? A to B 5, A to D 20 is correct, but A to C 10. A to C 10, yeah, it is same. A to C 10 we have taken, we have not done any changes, that is also correct. But A to E, now A to E, initially A to E was 15, but we have taken from C to E, so 10 plus 3 13. So A to E, we can say instead of 15, now we can say it is 13. So we can say A to C and C to E 13, right? And A to C and C to F, it is 12. So A to F we can say 12. A to F we can say 12. So this is the final graph with the how many number of edges with minimum cost. So this is the final answer for Dijkstra algorithm. So in that way we can calculate the time complexity, or we can calculate the minimum cost path with the Dijkstra algorithm by doing comparison.